So let's start a new chapter, chapter 5. We start from section 5.1. Tell you something about basic concepts in geometry. You need to learn several concepts like points, lines, and surfaces. First of all, we need to know the difference between a straight line and a line segments. Okay? And then you learn the angles and identify different types of angles. And then you learn the concept of parallel lines, perpendicular lines. Okay? So first of all, you need to know what is a line segment here. Look at the key points. Line segment. Okay, first of all, we have a point, say P. Okay? Put a cross here, label it P to represent a point, P. And then put a cross here with another letter Q. So joining these 2 points with a straight line. Okay? And this line should have a length, say 4 cm. So this is a line segment, PQ. Okay, we can simply write this PQ equal to 4 cm. So PQ is a line segment. And then we have a concept of angle. What is an angle? For example, we have two line segments, AB, intersecting the other line segment, BC, at the point B here. And then we are going to label the angle that AB made with BC. And we are going to name this angle. You can name it with any letter, say, for example, small letter B. But a more systematic way to name it is the following. We can start from using the angle symbol here. This is the angle symbol. Start from the line segment endpoint A, goes to B, and then finally C. So the middle letter is the target angle position. And then the small angle B will be just angle ABC. Equally, you can name this starting from C, going backward, angle CBA. They are the same. Okay, that's how we named angle. Okay, types of angle. We can classify angles by the size. Okay, so the size is you can use a protractor to measure the angle size, and the degree is the units for angle degree. The small circle here is the unit for angle degree. And for example, if you put a protractor over this angle, you find this angle is less than 90 degrees, and it is named acute angle. And you can have a right angle that is exactly 90 degrees, and this angle can have a very special notation like a square at the corner. And then you can have obtuse angle. This angle is greater than a right angle but smaller or less than 180 degrees. Less than 180 degrees, greater than 90 degrees. So this is called an obtuse angle. For angles that are like a straight line here, this angle is exactly 180 degrees. That is two right angle, and this angle is called a straight angle. Larger than a straight angle, but less than one complete circle, then this is called a reflex angle. Reflex angle. And then for one complete rotation, here we have 360 degree. That represent a whole circle here, and that is a round angle. Okay, just the names, you need to memorize all the names. They will appear in UT and exam. Okay, now check the following. Determine whether each of the following statements is correct. If it is correct, put a tick. So, two straight lines must intersect at one point. Two straight lines must intersect. I can have a counterexample. These two straight lines, imagine you have two straight lines. No matter how long you extend them, they will not intersect. These pairs of lines are called parallel lines. Okay, so they are not intersecting no matter how long you extend it. And then these two straight lines, this is not a must for two straight lines intersect. Normally you can have intersecting point, but for these parallel lines, they will not intersect. Okay, question B, there are infinitely many points on a line. Okay, so this is a line, and if you look at points here and points there and points here, seems there are infinitely many points on this line, because if you zoom in this part, zoom in, and then you can have a longer line here, and then you can continue this process. Zoom in here, you have long line, and then you have 2 points here. So you can continue and continue this process, and actually there are infinitely many points on a line. Correct? The size of an obtuse angle can be 90. No, by definition, obtuse angle should be greater than 90. The size of a reflex angle can be 145 degree. So what is reflex angle? Greater than 180, less than 360. So no. Okay. Name all the line segment. Okay. Write down line segments. All the line segments include PQ, QR. Should be very simple. Or you can write or QP, RQ the same way. Question B, you can have AB, BC, CD, DA, and also AC. So they are, okay, using AB, BC, CD, DA, and AC. Right? Mark all the angles. Of course, you can have angle BAC first for this, and angle CAB for this. C angle CBA. Okay, the middle one is the place of the angle. Of course, you can have or CAB here, the same thing as BAC and ABC. Okay, name the marked angle. Pause it, name it by yourself. Of course, you can. Okay, angle PQR and also angle PSQ, right? Do some matching. 30 degrees correspond to acute angle. 90 degrees should be the right angle. 110 obtuse. And this is a straight angle. This is reflex. And round angle is what? 360. Quite simple, right? If you memorize all the names. Name the type of angles marked in the figure. This one is 90 degrees, is a right angle. Okay, name it by yourself. Okay, pause it, do it. B, obtuse angle. C, reflex angle. Straight line, straight angle. And then P, acute angle, right angle, obtuse angle, and reflex angle. Okay, next page. 3 right angles means 3 times 90 degrees. That gives you 270. Straight angle is 180 degrees. 60. Round angle is 360 degrees. 270, right? Remember a little circle here for the unit. So next, we talk about parallel lines. I've just mentioned if two line segments never meet each other, like these two lines, then we have a notation of this. Okay, AB parallel CD, AB parallel CD. That means these two line segments never meet. And of course, we have perpendicular lines on the other hand. They meet and they also meet at right angle. Okay, so AB, this line, meets CD at right angle. CD at this right angle. Okay, so we say AB perpendicular CD. Okay, so mark all the parallel lines, perpendicular lines in the following figure, question 7. Okay, so parallel lines, we have one pair. Put an arrow to represent parallel lines. AD parallel BC, so put an arrow here. And also AD parallel BC here, and also AB is parallel to CD, but we already use one arrow to represent parallel lines, so we put double arrow here to represent the other pair. Okay, and then we have to mark as well the perpendicular lines. Okay, we know this line is perpendicular, BE is perpendicular to AD, and EB is perpendicular to also to BC. Okay, so these are the notations. Okay, indicate all parallel lines here, perpendicular lines for the following figure. It is a rectangle. Okay, by definition, you know there are 4 right angles at the corner. and then that means AB will perpendicular to AD, and similarly AB perpendicular to BC, so on and so forth. And you have two pairs of parallel lines. This is parallel, and AB parallel to DC as well. So mark it all. And question 9, mark all the parallel lines here. So parallel lines, BA will be parallel to ED. Perpendicular lines, just one. BC perpendicular to what? DC. Okay, again, parallel lines. We have two pairs, AB parallel DC, and also AD parallel to BC. Perpendicular lines, we have AB perpendicular to DB, and also BD perpendicular to CD. Something like this. Simple. And then next we talk about plane figures. So first of all, we need to know something about a circle. And then we learn something about triangles and their classification according to the size, side length, and then their angles. And we are going to learn a very important theorem called angle sum of triangle. That sum of all the interior angles of a triangle is 180 degrees. And then finally, we learn the concept of polygons and classification of polygons. So let's start with a circle. Oh, this is a circle. And here we have the center O of the circle, center O. And then this is the radius. From O to any point on the circle, this is the radius. You can have this point to any point, and they are all the radius. All the radius are the same, actually, same size. And if you have a straight line through the center like this is called a diameter. So the straight line through the circle, through the center of the circle as well, then line AB here is a diameter. Of course, you have infinite number of diameters in a circle. And of course, we have a relationship that the diameter length D will be just 2 times the radius length R. And the circumference here, what is the circumference? This is the circumference. The length of the whole circle is the circumference. Of course, we have learned it. The length L will be 2 pi R. Okay, anyway. So next we talk about some types of triangles. Classify it by the length of the sides. If we have 3 sides are all equal, we have equilateral triangle. Equilateral triangle, 等邊三角形. 3 sides are all equal. Okay, the notation for 3 sides equal is put a dot on each side. Okay, sorry. And if only 2 sides are equal, we call it isosceles triangle. Isosceles. Put 2 dots here. represent these two side lengths are equal, but the base lengths can be different. And the third type is scalene triangle with all three sides are unequal. Okay, we have this. So the first have three sides equal, three side equal, two side equal, and no side equal. And then classify by size of angles. You look at the angles, the interior angles to be exact. So you have all three angles less than 90 degree, all are acute. So this triangle is called acute angle triangle. And with a right angle here, this triangle called right angle triangle. And if you have one angle greater than a right angle, less than a straight angle, that's an obtuse angle triangle. So very simple to name these types of triangle according to the side and the length, size of the angles. Okay, so what is the radius of the circle? Quickly, we can write down 2 here. And their diameter, 4. Okay, so using a ruler, classify each of the following triangle according to the lengths of their size. We have 3 names. This, and this. Okay. 3 sides equal. The first triangle, equilateral triangle. Okay. The second one with these 2 sides equal, isosceles triangle. With all 3 sides unequal, these triangles are called scalene triangle. Okay, use a protractor, classify the following angles, triangles according to the angles, the size of the angles. You have a right angle here. So this is called right angle triangle. And these 3 angles are acute. So acute angle triangle. And then with one obtuse angle here, this is called obtuse angle triangle. Just some names. And the following theorem is very important. Okay. The name of this theorem is angle sum of triangle. Angle sum of triangle. And abbreviation is the short form to write this theorem is this one, angle sum of triangle. That means if we sum over all the interior angles A, B, C, the sum is 180 degree. This one. This applies to any triangle, okay? To any triangle. So, using this theorem, solve question 4A for this unknown angle B. Okay, because we have this theorem, angle sum of triangle, this theorem, if you apply it, you write this. sum of three interior angles equal to 180. D would be 45, E will be 65, and we have an unknown B, add up to 180. So just solve this equation quickly. And the answer should be 70 degrees. So every time you need to write the reason when you use this relationship, the box relationship here. Okay, try question B. Okay, we have in triangle QPR, 90 degrees for Q plus 65 degrees for P plus Y equals to 180 degrees. Write the reason. Angle sum of triangle. And then solve for Y like this, and Y will be 25 degrees. Right. And then find the unknown X in the following figures. For part A, 40 degrees plus X equals to 180. So 40 plus 2x, 180, and then something like this. You can easily solve for X. And then try it for B. Don't skip it. Okay, in X triangle XYZ, okay, 3x plus x equal to 180. The reason is angle sum of triangle. 5x 180, x will be 36 degrees. That's it for B. And you are going to determine whether each of the following sets of interior angles can be the interior angles of a triangle. So let's check it. If they add up to 180 degrees, then this set can be the three interior angles. It really adds up to 180 degrees. If you carefully add these three numbers up, it is really 180 degrees. So this set of angles can be three interior angles of a triangle. Okay, similarly, check B. 32 plus 75 plus 93. What's the number? What's the sum? Is 200 degrees. It is not equal to 180 degrees. So the conclusion is this set of angle cannot be three interior angles of a triangle. Right? Finish? Yes. Now let's look at different types of a polygon. Okay, so we can name it according to the interior angles. Actually, for all interior angles less than 180 degrees in a polygon. For example, here we have this angle less than 180, and all these angles are less than 180. So we name this type of polygon a convex polygon. Convex polygon. And then think about this figure. A Chinese word "dat." Is it a convex polygon? You check all the interior angle. This okay, this okay, this okay, this okay. But this is larger than 180 degree. This is larger than 180 degree. So this is not a complex polygon. This is not. Rather, it is a concave polygon. Next to it, we have concave polygon with at least one angle greater than 180 degree. So this actually is a convex polygon. Okay. How about a figure like this? It is also a convex polygon, right? With this angle larger than 180 degree. Okay, equilateral polygon means all sides are equal. Equilateral means all sides are equal. Equiangular means all angles are equal. All interior angles here are equal. And finally, regular polygon means all sides and all angles here are equal. So let's move on, try to figure out which of the following figures are convex polygon. Convex. Okay, first of all, with an angle like this is not a convex polygon. So A is a concave polygon. So check B, this one, this one, this one. All angles here less than 180. So B is a convex polygon. And also C is also less than 180 degree. C is a convex polygon. And D also a convex polygon. Check all angles. This angle larger than 180. So this is a concave. And also this angle. These angles are greater than 180. So F is a concave polygon. Quite simple, right? And then which of them are equilateral polygon? Equilateral, equiangular, regular. You know the difference of all the three types of polygon. Equilateral means all sides equal. This one okay, not okay, not okay, okay. So AD, right? For equiangular, all angles are equal. These angles are equal. Angles are equal. Not all angles are equal because we have these two angles not equals to the other angles here. And all angles equals here. Okay, A, B, D. And which of them are regular polygons? So both A, B should be satisfied. Both A and B should be satisfied. Equilateral and also equiangular. And then you can find AD should be regular polygons. Okay, consider two polygons on the right. Use given letter to name the polygon. Figure 1. How to name the polygon? Just name it according to start with a letter first. Start with a corner P, going from P to Q, and then clockwise go back. Okay, you don't need to. So this is P, Q, R, S. The figure 1 is PQRS. Or you can name it in other way, or starting from R, you go from R to Q and P and S. Still okay. Starting from R, you go in this way. So try to name figure 2. Starting from F, go this way, will be F, G, H, D, E, right? Or any other orders. But remember, you cannot name something like F, H, E, G, D. They are in wrong orders, right? No. And then you draw all the diagonals. What do we mean by diagonals? Diagonals is joining corner to corner. Okay. For example, I draw some diagonals on figure 1. From corner AP, you can draw a line through P to R. And also one line from Q to S. And no more other lines can be drawn, right? So you have 2 diagonals for figure 1. And try figure 2, starting from D, put diagonals to F, and then to G. Any other? No. Okay. Move from D to E. E can have 1 diagonal to H, 1 diagonal to G. Any others from E? No. And moved from E to F, so join FH, and no more, right? So how many diagonals here? 1, 2, 3, 4, 5. 5 diagonals. 2 diagonals here. Diagonal means 對角線. Okay? So the final section is about solid. We have some 3D figures. 3D figures. 立體. And we have to learn 2 types of solid first, polyhedra and non-polyhedra. So what is a polyhedra? This is a plural form. The singular form is polyhedron. What is a polyhedron? Polyhedron is a solid enclosed by polygons only. And you know polygons already. So a cube is enclosed by 6 polygons of actually 6 square, right? And for a cuboid, it is enclosed by 6 polygons, some rectangles, some other shapes. Like this side, we have a polygon of like a square. We have the other faces, like this faces is faces of rectangle. They are polygons. So a polygon, a polyhedron, is a solid enclosed by polygons only. And also we have a pyramid like this type is enclosed by some triangles and some quadrilateral. Then it is a polygon. Okay, now we have to know some concepts about a prism as well. A pyramid, circular cylinders, and circular cones. And then we have to learn the concept of cross-section. And also distinguish it between uniform cross-sections and non-uniform cross-sections. Okay, we will skip this 2D representation to learn the sketch. We don't need to learn the sketch. So let's start from polyhedron. I've mentioned that it is enclosed by polygons only. And for non-polyhedron, it will be look something like this. First of all, A is enclosed by polygons only, so it is a polyhedron with all 6 faces are polygons. But this cone, this is not cone, this is called a cylinder. This cylinder is enclosed by 2 circles and a curved surface. It is not a polygon, so this is not a polyhedron. And you can check if it enclosed by curved surface, it is not a polyhedron. So question C is again enclosed by polygons, it is a polyhedron. D again it is enclosed by a curved surface. This is called a hemisphere. A sphere is like a football. This is a sphere. Like the shape of the earth, it is a sphere. A hemisphere means half of the sphere, and it is a curved surface, so it is not a polyhedron. Okay, then we write down the number of vertices, edges, and faces of the following solid. So vertices means the corners. So we count the number of corners here. 1, 2, 3, 4, 5, 6, 7, 8. Should be 8. And also we can count the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. 12. Number of faces should be 6, right? And then check the others. You can count it by yourself. What are they? Number should be 7 vertices, 12 edges. Okay, count it for you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 12, right? And then faces should be 7. Okay, you can count it by yourself. 6 faces of triangle like this, and 1 bottom faces, 1 bottom face. Okay, count next figure. Number of vertices. 1, 2, 3, 4, 5, 6. 6 at the back, so 12. Number of edges. 6 here. 1, 2, 3, 4, 5, 6 there. And at the back 6, 18. Faces. 8 faces in total. And then here we have number of vertices 8, number of edges 12, number of faces 6. So these are the answers for all the polygons, all the polyhedrons here. And then we have a very famous formula called Euler's formula. Euler's formula for polyhedra. And this will be V minus E plus F equals to 2. The number of vertex V, the number of edges E, the number of faces F. According to this, we have this formula, always true. So let's try pick this as example C. We have 12 vertex, 18 edges, plus 8 faces. This expression will be just 2, right? So this relation holds for any solids polyhedron. Okay, you don't need to memorize this formula actually, but this formula is so famous, so I mentioned here. So next, we need to draw some cross section obtained when each of the following prism is cut at the gray line according to given plane. These are gray lines, okay? Like a knife cutting a birthday cake, okay? You cut it, and then the cross section, just draw it out. Okay, so it is very simple. If you have a ruler, you can draw it quite nicely. If you cut this figure, you have, okay, I change it to black, okay. Ooh. I just found a new function for the Apple Pencil. Yeah, that's very great. I can draw a straight line now. Okay, how about this? And then, oh, why it is curved? Yeah, this is like an arrow. Okay, next. Do the following solid have uniform cross section? Put a tick. So if you have a knife, cut it. Do the following solids have uniform cross section? If you cut it here, you will have a trapezium. So this is yes. If you cut it here, you again obtain the same cross section. If you put a knife on top, anywhere you cut parallelly, you can have uniform cross section. Uniform means the same. But if you cut the tetrahedron here, if you cut it here, if you cut it here, you will have different cross section. Even though you cut it sideways, you will have different cross section. So no. Okay, imagine how to have uniform cross section of the solid. You cut it here or here. You will obtain the same triangle like this. Okay, and a pentagonal prism, cut it here, cut it here, you will have the same 5 sides polygon. Okay, try to draw it better. Quite difficult, okay, but you know what I'm drawing. And then sketch the following solid. Sketch the solid. How to sketch a solid? Okay, this is very difficult for me, I think, but I try. quite good actually. Okay. Oh, why is curve? Of course, you have some dotted line here at the back. And then this one, draw. Okay, this. Oh, okay. Something like this, I think. Okay, so I think that's it. You can check all the answer at the back. That's a better drawing. Okay. We still have some names for polygon. I think I have to cover it in class. This is just a very simple, quick revision about chapter 5. Okay, so that's it for today. Thank you for listening.